All right, everybody, now we're going to determine if quadrilateral ABCD is similar to quadrilateral WXYZ, or basically just looking to see if these rectangles are similar. So first we're going to take a look at the corresponding sides, AB and WX. And so here we have our image, or our copy, over our original. So when we compare those two sides, we're going to have 25 over 18, or 25 divided by 18. And then if we look at another set of sides, we have x over y, and that would be corresponding with b over c. But notice we don't have a number there. But since this is a rectangle, we do know that since one side is 45, the side opposite of it is also going to be 45. Just like over here, 36, the side opposite of it would be 36. So we could write this as 45 over 36. And now we need to see if these two ratios here are equivalent. And so can we reduce these ratios? Well, I noticed that I can't really reduce 25 over 18. And I could reduce 45 over 36. If I divided both by 9, I'd have 5 over 4. But since we can't reduce that top number, let's go ahead and just divide. Because remember, when we write something as a fraction, or we have that little sign there separating our 25 and 18, that is saying we can divide. So if we do 25 divided by 18, I'm going to go ahead and pull it up on my calculator here. 25 divided by 18, it gives us 1.38 repeating. And then if we do 5 divided by 4, well, I already know it's going to give me a different number, but let's go ahead and just try it out anyways. 5 divided by 4, that gives us 1.25. So notice 1.25 is not equivalent to 1.38. And so therefore these ratios, 25 over 18 and 45 over 36, are not equal. And when they're not equal, then that means that these two rectangles are not similar. Because remember, they have to have ratios of their side lengths, right? Image over original, that have the same reduced ratio here. So like 1.38 is not equivalent to 1.25, therefore they're not the same ratio. If we look down at the first workshop question here, we have rectangle ABCD and rectangle LMNO. So if AB is with LM, we write it as the image over the original. So here we have our image, here we have our original. So I'm going to write it as 15 over 10. 15 corresponds with 10, and that would reduce to 3 over 2 if we divide both by 5. And then if we look at 21 over 14, right, MN over BC, it's going to be 21 over 14, and that's going to be equal to 3 over 2 as well if we were to divide both by 7. Okay, on top we divided both by 5. And this is just to reduce it, okay? So here we have 3 over 2 as a reduced ratio. 3 over 2 is our reduced ratio. And this is for LM over AB. And then below, that was for MN over BC. And notice we don't have any new side lengths because NO is just going to be a mirror image of LM, just like LO is going to be a mirror image of MN because they're rectangles. So this is all we have to do. Since they are equal ratios, then we can say that they are similar. So let's take a look at some key points here. Since 1.38 or 25 over 18 was not equal to 45 over 36, right? When we divided 25 by 18 and 45 by 36, we got different answers here, right? They were not equal. Then they weren't similar figures. But when we divided 15 by 10, we get 3 over 2 or 1.5. And if we divided 21 by 14, we get 3 over 2 or 1.5. And since we got the same number here, then they are equal ratios and therefore they are similar figures. Okay, so it's all about finding those equivalent ratios. All right, so then you would do the same thing here for EFGH to see if it's similar for RSTU. Remember, what we do here to solve is take the image and put it over the original. And again, this is going to be the image over here. This is going to be the original. And one thing I'd like to note is that sometimes you'll see this as new over the old. Okay, you might call this the old one, and you might call this shape the new one. I've also seen it as like figure 1 or figure 2 over figure 1. And lastly, I've also seen it as like copy over the original. So these are all ways that I have seen image over the original written, but they all mean the same thing. Okay, this is going to be an image. This is going to be the new figure. This is going to be a copy of the new figure. And this is the old one, the original, whatever else you want to call it, okay? So I just want you to all know, in case you ever like watch a video, that it may be called something different than image over the original. But the concept is still the same, where you take the side length from the second figure, the image, and you put it over the side length of the original, or on the left side, the original. So image over the original. And be sure to please show your work just like I did for problem 1. And then you're going to complete this page here. We go through 3, 4, and notice you're going to have to pay close attention to where these angles are, okay, and where these sides are now located, because in this example here we see that the triangle was rotated, and now my right angle, for example, side P, is over here with side K. So that means that like side 17 is going to align with side 34. And if we took a look at a different side, we'd say side 15 aligns with side 30. So it's very, very key that we take a look at which angles are corresponding and which sides are corresponding. That's why we started off with the activity we did today.